Hello students, welcome back to another session of science class. In our last class, we have discussed some concepts about sound. In this class, we will discuss some more concepts about sound. Okay? Students, let us now discuss example 12.3. A ship sends out ultrasound that returns from the seabed and is detected after 3.42 seconds. If the speed of ultrasound through seawater is 1531 meter per second, what is the distance of the seabed from the ship? Let us now discuss the solution. Okay? Students, the time of travel, that means the time interval between transmission and detection is given as 3.42 second. Okay? Speed, that is given as 1531 meter per second. Distance travelled by the ultrasound, distance, that is equal to 2d, isn't it? It goes and comes back. Okay? So 2d is equal to v into t. So 1531 into 3.42. Okay. So it gives us 5236 meter. Fine. So the total distance travelled by the sound is 5236 meter. So the question asked about the distance of seabed from the ship. So this is the total distance. So the distance of seabed from the ship is half of this distance, that is equal to 5236 divided by 2. 2618 meter. Okay, or we can say 2.618 kilometer. Okay. Thus the distance of the seabed from the ship is 2.618 kilometer, or when we round it up, it becomes 2.62 kilometer. Fine. Hope you understand this example. Students, let us now discuss a question that is given in your book. A submarine emits a sonar pulse which returns from an underwater cliff in 1.02 second. If the speed of sound in salt water is 1531 meter per second, how far away is the cliff? Let us now discuss the solution for it. Okay? Students, it is given that t is equal to 1.02 second and v is equal to 1531 meter per second. Okay? So distance d is equal to v into t, that is 1531 meter per second into 1.02 second. When we calculate, that comes up to 1561.62 meter. Students, as mentioned earlier, bats search out prey and fly in dark night by emitting and detecting reflections of ultrasonic waves. The high-pitched ultrasonic squeaks of the bat are reflected from the obstacles or prey and return to bat's ear as it is shown in figure 12.18. The nature of reflections tells the bat where the obstacle or prey is and what is it like. Porpoises also use ultrasound for navigation and location of food in the dark. Students, let us now discuss structure of human ear. How do we hear? We are able to hear with the help of an extremely sensitive device called the ear. It allows us to convert pressure vibrations in air with audible frequencies into electric signals that travel to the brain via the auditory nerve. So students, let us discuss the auditory aspect of human ear. Okay? Student, just concentrate on figure 12.19 that is given in your book. The outer ear is called pinna. It collects the sound from the surroundings. The collected sound passes through the auditory canal. At the end of the auditory canal, there is a thin membrane called the eardrum or tympanic membrane. When a compression of the medium reaches the eardrum, the pressure on the outside of the membrane increases and forces the eardrum inward. Similarly, the eardrum moves outward when a rarefaction reaches it. In this way, the eardrum vibrates. The vibrations are amplified several times by three bones. Which all are they? The hammer, anvil and stirrup in the middle ear. The middle ear transmits the amplified pressure vibrations received from the sound wave to the inner ear. In the inner ear, the pressure vibrations are turned into electrical signals by the cochlea. These electrical signals are sent to the brain via the auditory nerve and the brain interprets them as sound. Hope you understand this. Students, let us now discuss what you have learned. Sound is produced due to the vibration of different objects. Sound travels as a longitudinal wave through a material medium. Sound travels as successive compressions and rarefactions in the medium. In sound propagation, it is the energy of the sound that travels and not the particles of the medium. Sound cannot travel in vacuum. The change in density from one maximum value to the minimum value and again to the maximum value makes one complete oscillation. The distance between two consecutive compressions or two consecutive rarefactions is called the wavelength lambda. The time taken by the wave for one complete oscillation of the density or pressure of the medium is called the time period t. The number of complete oscillations per unit time is called the frequency and it is equal to 1 by t. The speed, frequency and wavelength of sound are related by the equation speed is equal to wavelength into frequency. The speed of sound depends primarily on the nature and the temperature of the transmitting medium. The law of reflection of sound states that the directions in which the sound is incident and reflected make equal angles with the normal to the reflecting surface and the three lie in the same plane. For hearing a distinct sound, the time interval between the original sound and the reflected one must be at least 0.1 second. The persistence of sound in an auditorium is the result of repeated reflections of sound and is called reverberation. Sound properties such as pitch, loudness and quality are determined by the corresponding wave properties. Loudness is a physiological response of the ear to the intensity of sound. The amount of sound energy passing each second through unit area is called the intensity of sound. The audible range of hearing for average human beings is in the frequency range of 20 Hz to 20 kHz. Sound waves with frequencies below the audible range are termed infrasonic and those above the audible range are termed ultrasonic. Ultrasound has many medical and industrial applications. The sonar technique is used to determine the depth of the sea and to locate underwater hills, valleys, submarines, icebergs, sunken ships, etc. Students, let us now discuss some of the questions of the exercise. Okay? Students, let us discuss the first question. It says, what is sound and how is it produced? And the answer is, sound is a mechanical energy which produces a sensation of hearing. When an object is set into vibrations, sound is produced. Okay? So hope you have understood the answer for question 1. Question 2 says, describe with the help of a diagram how compressions and rarefactions are produced in air near a source of sound. Students, we have already discussed with the diagram and hope you have clearly understood the concept. So hope you can find the answer by yourself, isn't it? Question 3 says that cite an experiment to show that sound needs a material medium for its propagation. Students, in our previous classes, we have already discussed this experiment. So hope you can find the answer for this question. The next question is, why is sound wave called a longitudinal wave? So let us discuss the answer. Okay? Students, sound wave is called longitudinal wave because the particles of the medium vibrate in the direction of the propagation of wave. Okay? Hope you understand the answer. The next question is, which characteristic of the sound helps you to identify your friend by his voice while sitting with others in a dark room? Let us now discuss the answer. Okay? So students, as we have discussed in our earlier classes, the quality of sound or the characteristic of the sound that helps us to identify any sound among many sounds is called quality of timbre. Okay? Hope you understand the answer. Students, with this we come to the end of the chapter, sound. We have discussed many concepts of sound and we have gone through some question answers. Revise all the concepts. So keep practicing and keep smiling. Thank you.